Look along the shores of the Dead Sea right now, and you might spot an unnatural anomaly: vivid pink pools dotting the barren rocks. This shift in color marks a tipping point in the sea's chemistry. As the water evaporates, it becomes so hypersaline that halophilic, or salt-loving, microorganisms are the only life forms left that can thrive, blooming in massive numbers across the basin. The collapse extends deep underground. As the heavy saltwater recedes, fresh groundwater rushes in behind it, dissolving ancient subterranean salt layers and hollowing out hidden, massive cavities. Eventually, the surface gives way. Over 6,000 sinkholes have violently torn open along the coastline, completely swallowing up roads, tourist resorts, and huge stretches of land. This destruction is driven by one brutal metric: the Dead Sea's water level is dropping by more than a meter every single year. We are witnessing a rapid, well-documented collapse. But the tragedy isn't a lack of information. Engineers have already drafted the exact blueprints required to save the basin. Yet as the water vanishes, not a single one of these plans has been put into motion. To understand why, we have to look at the basic math of how the Dead Sea gets its water. Historically, its lifeblood has been a single source: the Jordan River. This map of the Jordan River basin illustrates the problem. Upstream nations, Israel, Jordan, and Syria, have diverted nearly all of the river's fresh water to support agriculture and drinking supplies in the desert, reducing the once mighty flow into the Dead Sea to a mere trickle. While the faucet is turned off, the drain is wide open. Extreme heat and a shifting climate are accelerating natural evaporation, but human industry is actively pumping the remaining water out. Both Israel and Jordan operate massive industrial evaporation ponds directly on the shores. They pump out huge volumes of water to extract lucrative minerals, like potash, for global fertilizer markets. The physical byproduct of this operation is immense. The industry piles up huge accumulations of waste salt across the basin, adding a layer 20 centimeters thick to the surface every single year. Between the basic need for human survival and powerful regional economic interests, the Dead Sea's natural water cycle is completely broken. Politicians and engineers have spent decades proposing megaprojects to fix this. The most famous is the Red Sea-Dead Sea conduit. This pipeline diagram details the ambitious mechanics. Pump 300 million cubic meters of ocean water from the Red Sea, desalinate it to provide fresh drinking water for the region, and dump the leftover heavy brine directly into the Dead Sea to refill it. But as this graphic visualizes, there is a fatal environmental catch. Mixing ocean water with the unique chemistry of Dead Sea brine risks a violent chemical reaction. It could instantly form gypsum, turning the entire surface of the sea into an opaque, milky white. Recently, Israel's Environment Ministry announced a domestic alternative, proposing a massive pipeline to channel water in from the Mediterranean Sea instead. Yet that project wouldn't be operational until at least 2045, which is decades too late, and it carries the exact same severe financial and chemical risks. What about the immediate alternative? Just shut down the massive mineral extraction operations on the coast. That is a complete political non-starter. Halting those operations would devastate the surrounding economies and eliminate thousands of jobs. Every proposed fix carries a severe downside. The current situation is one of total diplomatic stagnation. While formal agreements to save the sea exist on paper, the massive financial requirements and the fear of triggering an even larger ecological or geopolitical disaster has kept every project from ever breaking ground. Any real attempt to address the root cause, the upstream diversion of the Jordan River, requires intense trust and complex water-sharing agreements between nations locked in historical conflict. So the inaction continues, and the physical scars grow deeper. The receding waterline leaves behind a disintegrating, lifeless landscape of stark white mineral terraces. In one of the most volatile and water-stressed regions on Earth, leaders are choosing the path of least resistance, doing absolutely nothing. It forces an unsettling question. If saving a natural wonder means risking a fragile regional peace, destabilizing economies, or jeopardizing fresh drinking water for millions of people in a desert. Is it actually the right thing to do? The Dead Sea will continue to shrink, leaving behind those beautiful, toxic pink pools. And that slow demise might be the brutal, unavoidable price of human survival in the modern desert.